we will talk about a couple of like specific dynamics for the motion of spring. Okay, so we're gonna start from undamped free vibration. Okay, so let me try to explain what that means. Okay, first of all, as we make the dynamic model of the like spring motion, and we consider about like couple of like forces, right? The first one was the spring force, right? The second one, damping force, which is like kind of like a resistance of the air or other factors, right? And the like third one was external force, which means you're going to apply like more force every single time, right? And that is like there are like three things, okay? But what is the undamped free vibration? Undamped means there's no damping term, right? And what is free vibration means? There's no external force. So which means like, okay, let me write the like spring model first, what we derived like in the previous slide, okay? It was M U double prime plus gamma U prime, that is damping term, right? And plus Ku, which is spring force, and is equal to external force, right? And undamped free vibration means undamped, damping term equals zero, and free vibration, external force equals zero. Okay. So finally, you will have like this differential equation now. Okay. Mu double prime plus Ku is equal to zero. This is undamped free vibration. Okay. So now look at this equation. That's really easy, right? That is second order, homogeneous second order linear differential equation with constant coefficient M and K, right? Definitely we can solve this one. How can we do it? We have to start from the characteristic equation, right? The characteristic equation for this second order differential equation is M R squared plus K is equal to zero. How can you solve it? It's very easy, okay? We're gonna move your K to the right-hand side and divide by M and take the square root. That's it, okay? So minus K on both sides. And divide by M on both sides. And take the square root on both sides, right? But don't forget you must have plus and minus sign in front of this right-hand side, okay? But keep that in mind. Coefficient, I mean, like, spring constant K and the mass, all those are positive. So which means you have negative number under the square root, which means you have imaginary number, right? Which is plus and minus and square root of K over M times I, okay? So for my convenience, let's say square root of K over M as omega, okay? And then, like, you look at that. We learned about how we can write the like solution of this differential equation with the imaginary number, right? So we're gonna use Euler formula, right? So your solution form ut, your real number part equals zero, and imaginary number is omega now, right? So that is equal to first coefficient C1, or we can say just A times e to the 0 times cosine omega t plus another coefficient b, C2 or b, it's 0 and sine omega t. So which is equal to a cosine omega t plus b sine omega t. That's it, right? But like, but keep that in mind. We are talking about undamped free vibration, okay? Imagine about your solution curve, undamped. There's no external force. What happened? It will start oscillation and there's no deceleration, okay? So it's just going like this oscillation forever. Does it make sense? That is the meaning of like undamped free vibration, okay? So basically we can assume like it will be just like simple trigger function form, which means just oscillation forever, okay? So we're gonna try to change this solution form, which is cosine plus sine form, as one single trigger function. Like for this class, we're gonna change as the like one single cosine function, okay? And what is the benefit of like to change that one? Like we can talk about amplitude. Well, like do you remember one of the like homework problem? I asked you to find amplitude, right? And that is because with this technique, okay? Amplitude and frequency or period or phase easily, right? If you have sine plus cosine form, it is not easy. But as soon as you have like one single cosine function form, then it will be easy. Okay. So you should know. I believe that you studied this already, but like let me try to give you the formula how we can combine this one as one single form. Okay. So it is here. It can be written by square root of a squared plus b squared times cosine omega t minus delta. And like we say, okay, so to make it simpler, let's say this square root of a squared plus b squared as r, okay? Then we can write this one as r cosine of, oh, we don't have enough space though, omega t minus delta. And what is this delta? Delta is equal to actually tangent delta, okay? Tangent delta is equal to b over a. Is that okay? So we can easily talk about the like all the frequency and phase and amplitude and what was it? Period, right? But like wait a minute. Whenever you have this one, and some of you are asking, hey JD, like where this like tangent delta came from? Okay, it is good question. Okay, so it is kind of like, do you remember like one of the like trig function identity things? Okay, do you remember cosine x minus y? Okay, let me show it to you. Okay, like a little. Okay, so since cosine, for example, just is simple comparison. Okay, x minus y is equal to cosine x times sine x sine y plus oh no, what am I doing? Let me write it. Okay, cosine x minus y is equal to cosine x cosine y plus sine x sine y. Okay, so we're gonna use this formula for like the final result, and like we're gonna compare with like ma initial solution curve. Okay, so look at that. From this one, if I say r cosine omega t minus delta, apply this one to this solution, then that can be written by r cosine omega t and delta. And let me change the order. Let me write like cosine delta first and cosine omega t and plus r. Let me write like delta term first, okay? Sine delta and sine omega t, okay? Just try to compare this guy and this guy, okay? Then can you find it? Like, coefficient of cosine omega t is r cosine delta, but in the solution it was a, right? So we can say your a is r cosine delta and your b is r sine delta, okay? Then what is b over a? Which is r sine delta over r cosine delta. That is sine delta over cosine delta, which is equal to tangent delta. So your tangent delta equal to b over a came from this guy, okay? But keep that in mind. Like there's another important thing, okay? So like don't forget this, okay? Your coefficient b is constant with r sine delta, and your coefficient a is constant with r cosine delta, okay? This is a very important thing, okay? Because it depends on like where the delta the angle delta is, okay? Because like look at that. A is constant with cosine delta. That means like if your angle delta is in the first or fourth quadrant, and your a value must be negative, right? And if your, am I doing right? No, give me 1 second. Yes, a is negative, right? And if your delta is same thing, you know what I'm saying, right? Sine value and cosine value depends on like your delta, the sign of like a and b can be decide. Okay, we're gonna talk about this one in the next problem. Okay. Anyway, before then, let me try to complete like all this. Okay, and this is beside one, like I just explained where they came from. Okay, but anyway, your solution curve can be combined as one single trig function, which is cosine. Okay, and now let's focus on like r cosine omega t minus delta. And as you can see here, your amplitude is really obvious, right? Which is r, right? And look at this curve. Okay, your amplitude is r, and which is a maximum r and minimum is minus r, and your period is 2 pi over omega. Okay, but like in this graph, like oh, I found there is like your x-axis not t but like omega t, right? And it should be better to convert this one as the like just like graph of t and u instead. And amplitude, there's no change. Range is minus r to r, and graph shape will be same. And keep that in mind. There's no dissipation, but like it's going forever, right? Because it's undamped free vibration, right? And then your starting point is not delta, but we can write this one as delta over omega, because like your x-axis is like your t-axis is not the omega t anymore, but it's t, right? And then like also we can talk about the period is delta over omega plus 2 pi over omega, right? That is your period. And then frequency is like definitely omega, and the phase is delta, okay?